Hello everyone. In the previous videos we have discussed about the page replacement policy, FIFO page replacement algorithm, optimal page replacement algorithm, and today we are going to discuss about least recently used page replacement algorithm. As the name suggests, least recently used, that means we are discussing about the past. So from the current page of replacement we will be checking about the previous page string, that which page is used least recently in the page replacement process, and the page that has been replaced at the least recently, that will be replaced with the desired page under execution. So this is the algorithm which replaces the page that has not been referenced for the longest time. The page that has not been referenced for the longest time. By the principle of locality, this should be the page least likely to be referenced in the near future. By the principle of locality, we suppose that this page will not be referenced in the near future. This is the phenomena, or you can say strategy of the algorithm. Then, as you can see, we have to check for the past string for replacement of a page. We have to keep record of the pages replaced in the past, and for that, due to that, this is the difficult algorithm to implement, because in this one approach is to tag each page with the time of last reference, and then we can know which page has been referenced when, and we can identify the least recently used page by that time frame. So this requires a great deal of overhead. It needs a great overhead to maintain the record track of the pages that are referenced in the past. Another things about least recently used page replacement algorithm, that it is free from Baladi's anomaly. As we have already discussed Baladi's anomaly, that Baladi's anomaly is that the page that is being replaced can be used in the near future, but this algorithm keeps track of that thing, and the page that will not be referenced in the near future gets replaced. So it is free from Baladi's anomaly. Another problem is how to order the frames defined by the time of last use. We have to define, as we discussed, we have to keep track record of all the pages referenced in the past, but then comes another problem, that how do we order those pages, order those frames in the system according to the time of their usage. So for that we have a solution to use counters to keep order of the frames, or we can use queues. As the queue says, that the page that arrives first will be replaced first. So we can use any of the solutions. We can use counters to keep track record of the order, or we can use queue to track the order of the frames referenced in the past for replacement of pages, and then we replace the pages accordingly with the page that is least recently used. So let's proceed with an example. This is the example for least recently used algorithm. We are having the same string as we have used earlier in the FIFO and optimal replacement algorithms. So let's start with replacing the pages in the frame. Same concept is there. We are having the frame set with 3 frames, and first all the 3 frames are empty, and we start replacing the pages from the page string into the frames. So first we put the page 7 into the free frame, then page 0 into the second free frame, then page 1 into the third free frame. Then comes page 2. So we'll check the previous past history of the usage of the pages. In the previous list, the page that has been referenced least recently will be replaced. So 1 is recently referenced, 0 is recently referenced. So we will replace the page 7 with page 2, as it is the least recently used. Page number 7 will be replaced by page 2. So the now frame set has page 2, page 0, and page 1. Then comes page 0, which is already available in the frame set. Then comes page 3. Then we'll check for the pages that 0 is recently used, 2 is recently used, 1 is the least recently used. So we will replace 1 with the page 3. Then comes 0 page, which is already available, so no page fault. Then comes page 4. In the frame set, pages are 2, 0, and 3. The 0 is recently used, 3 is recently used, then 2 is the least recently used. So we'll replace page 2 with page 4. Then comes 2. In the frame set, now pages are 4, 0, and 3. So we'll check 4 is recently used, 0 is recently used, but 3 is the least recently used. So page 3 will be replaced with page 0. Then page 3 comes, and page 3 will be replaced with page 0, as page 2 is recently used, 4 is recently used, and 0 is the least recently used. So page 0 is replaced with page 3. Then comes page 0. In 4, 3, and 2, page 4 is the least recently used, so will be replaced with page 0. Then comes page 3, which is already available in the frame set. Then comes page 2, which is already available in the frame set. Then comes page 1, which is to be replaced with page 0 in the frame set, as 0 is the least recently used page. Now frame set has pages 1, 3, and 2. Then comes page 2 in the page string. Then it is already available in the frame set, so no page fault. Then comes page 0. So we have to replace page 0 with the page 3 in the frame set, as page 3 is the least recently used page. Then comes page 1, which is already available in the frame set, so no page fault. Then comes page 7, as 1 and 0 are recently used, so 2 is the least recently used page. So we'll replace page 2 with page 7. And now frame set has page 1, 0, and 7. Then comes page 0, which is already available in the frame set, so no page fault. Then comes page 1, which is already available in the frame set, so no page fault. So this is all about least recently used algorithms. Now we will find out about the total number of page faults in the algorithm. So let's count on: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So the page fault rate of the least recently used algorithm is 12 pages. Is 12. That means 12 page faults occurred in the algorithms, and we have made 12 replacements of the pages for execution in the system. So now you can compare the three algorithms: FIFO, optimal, and least recently used algorithms. That FIFO, with the same page string, FIFO was having 15 page faults, l- optimal page replacement was having 9 page faults, and the least recently used algorithm is having 12 page faults. So from the page fault rate, we can find out very easily that optimal replacement is the best algorithm, least recently used algorithm is the better algorithm, and last one is the FIFO algorithm, which is according to performance is very poor algorithm to be used, as it has the maximum number of page faults that can happen in the system. So least recently used algorithm sits in between the optimal replacement algorithm and FIFO page replacement algorithm. So this is all about least recently used algorithm. Thank you very much. Later on we'll be discussing another variation of least recently used algorithm, that is approximation based algorithms in least recently used algorithm. So thank you for now.